projects. In this video, we are going to explain about the project titled Global Local Enhancement Network for Short Text Classification. A modern deep learning framework called the Global Local Enhancement Network (GLEN) for short text classification was created to handle the difficulties associated with correctly identifying brief text passages like tweets or headlines. The classification of short text is a crucial task in many applications, such as sentiment analysis and news classification. With the aid of attention mechanisms, GLEN makes use of both global and local context information in brief text to identify key contextual signals. The goal of GLEN is to dramatically increase the performance and accuracy of brief text classification tasks by incorporating these contextual factors, thus boosting the usefulness of natural language processing systems in the era of condensed and equally generated textual information. The project's goal is to create a thorough method for correctly categorizing brief text samples like tweets or headlines. Data exploration and pre-processing, which includes data cleaning and visualization, are the first steps in this multi-step process. To extract useful features from the text, the project uses sophisticated tokenization approaches based on BERT for transfer learning (TL) and Keras for deep learning. It then divides the data into training and testing groups and creates a number of deep learning models such as the BiLSTM, BiRNN, BiGRU, GRU, LSTM, CNN, and an ensemble model that combines the LSTM with the GRU and CNN. The goal of these models is to increase classification accuracy while tackling the difficulty of successfully accessing brief textual information for a variety of applications. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows only, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements. In software requirements, we have Anaconda 3 and Visual Studio Community version. Flow of project. To implement this project, we have designed the following modules. The first module is importing the packages. This module involves importing various libraries and packages in a programming environment, typically in Python. These libraries provide the necessary tools and functions for tasks such as data manipulation, visualization, machine learning, and deep learning. Commonly used packages in natural language processing (NLP) and deep learning projects include NumPy, Pandas, TensorFlow, Keras, Matplotlib, Seaborn, and more. Second module is exploring the dataset. In this module, the project team analyzes the dataset to gain a deeper understanding of its structure and content. This includes examining data statistics, distributions, and characteristics, as well as identifying potential challenges or patterns. Exploratory data analysis (EDA) helps in making informed decisions about data pre-processing and model selection. Visualization. Data visualization is a crucial step in understanding and presenting insights from the dataset. This module involves creating various types of graphs, charts, and plots using libraries like Matplotlib and Seaborn. Visualization helps in identifying trends, anomalies, and patterns within the data, making it easier to communicate findings to stakeholders. Data cleaning. Data cleaning is the process of identifying and rectifying errors or inconsistencies in the dataset. It involves handling missing values, removing duplicates, correcting data types, and addressing outliers. Clean data is essential for accurate model training and predictions. Tokenization based on BERT for TL and Keras for deep learning. Tokenization is the process of breaking text into smaller units, typically words or subwords. Tokens. In this module, tokenization is performed using two different approaches. BERT for transfer learning. TL. Tokenization based on BERT, bidirectional encoder representations from transformers, is used for pre-processing text data. BERT tokenization is powerful as it can handle subword level representations and capture context effectively. Keras for deep learning. Keras-based tokenization is likely employed for preparing text data for deep learning models. It involves converting text into numerical sequences that can be fed into neural networks. Splitting the data into train and test. Data splitting is a critical step in machine learning and deep learning. The dataset is divided into two subsets: training data. This subset is used to train the machine learning or deep learning models. It serves as the input for model training. Testing data. This subset is kept separate and is not used during training. It is used to evaluate the model's performance and assess its ability to generalize to new, unseen data. Building the model, in which we have different algorithms. BiLSTM, bidirectional long short-term memory. BiLSTM is a type of recurrent neural network RNN that processes sequence of data bidirectionally, meaning it considers both past and future information for each time step. It is particularly effective at capturing long-range dependencies in text data. BiLSTM is suitable for text classification tasks because it can capture contextual information and relationships between words in a sentence. BiRNN, bidirectional recurrent neural network. Similar to BiLSTM, BiRNN processes sequence in both forward and backward directions. However, it uses a standard RNN cell which may have limitations in capturing long-range dependencies compared to LSTM or GRU. BiRNN can still be useful for certain text classification tasks, especially when computational resources are limited. BiGRU, bidirectional gated recurrent unit. BiGRU is another bidirectional RNN variant. It uses gated units similar to LSTM but with a simpler architecture. GRU is known for its efficiency in training and is capable of capturing context in sequences. BiGRU is well suited for text classification tasks due to its ability to capture context and dependencies in text data while being computationally efficient. GRU, gated recurrent unit. GRU is a type of recurrent neural network that uses gating mechanism to control information flow within the network. It is similar to LSTM but has a simpler architecture with fewer parameters. GRU can effectively capture sequential dependencies in text data and is often used in text classification tasks when computational resources are a concern. LSTM, long short-term memory. LSTM is a type of recurrent neural network designed to mitigate the vanishing gradient problem in standard RNNs. It is capable of capturing long-range dependencies in sequence and is equipped with memory cells to store and retrieve information over time. LSTM is a popular choice for text classification due to its ability to capture context and relationships between words effectively. CNN, convolutional neural network. CNNs are traditionally used for image processing but can also be applied to text data by treating text as one-dimensional signal. They use convolutional layers to detect local parameters and features in the data. CNNs can be used for text classification tasks, especially when dealing with fixed-length text inputs or when capturing local patterns is important. Ensemble model LSTM with GRU CNN. This ensemble model combines the strengths of LSTM, GRU, and CNN. It leverages the complementary capabilities of these architectures to improve classification performance. For instance, LSTM and GRU can capture long-range dependencies, while CNN can focus on local patterns. Ensemble models are often employed when seeking to enhance classification accuracy by combining the outputs of multiple models. Training the model. In this module, the selected deep learning models is trained on the pre-processed and split training data. During training, the model learns to make predictions based on the input data and adjusts its internal parameters to minimize the prediction errors. Model training is a crucial step as it allows the model to learn patterns and relationships within the data, enabling it to make accurate predictions on new unseen text snippets. Building the model with LSTM gives better accuracy. Flask framework with SQLite for sign up and sign in. Flask is a Python web framework used for building web applications. In this module, Flask is employed to create a web-based user interface for the project. SQLite, a lightweight relational database, is used for user authentication, enabling users to sign up and sign in to the application. This module provides a user-friendly interface for interacting with the trained text classification model. Users can access the service through a web browser, sign up for accounts, and log in to make predictions on their text data. User gives input. In this step, users provide input text data through the web interface created using Flask. Users may submit short text snippets such as tweets or headlines that they want to classify or analyze. User input is the raw data that the model will process and classify. It serves as the basis for generating predictions and insights. Trained model is used for prediction. The pre-trained LSTM model, which achieved the best accuracy during training, is utilized to make predictions on the user's input text. This model has already learned the patterns and features in the training data and can apply this knowledge to classify the user's text. The trained model's accuracy and ability to generalize to new data are critical for providing accurate predictions to users. Final outcome is displayed through front-end. The predictions generated by the model are displayed to the user through the web front-end. Users can view the classification results, which may include labels or categories assigned to their input text. The front-end serves as the bridge between the user and the model, allowing users to interact with the system and access the insights derived from the text classification model. Execution. To execute this project, first we need to open the code folder, which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model folder, which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, we need to type python space app.py and hit enter. After running the app.py file, the Flask framework will host the application locally at the default address. This is the address and port. Now copy this local link and paste this link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. This is the homepage of the project. Now click on sign up button. If we are a new user, first we need to register. But I have already registered, so click on sign in. This is the login account form. Enter the username and the password. And click on register. This is the home page of the project. So here we have the text box in which we should enter the message, and after entering the message we will predict the sentiment of the tweet. So here I am entering the message from the notepad. This is the message which I have entered. Now click on predict. So the results for the tweet are, the sentiment of the tweet is sadness. So we got the sentiment for the tweet as sadness. Now let us enter some more messages and find the sentiment of the tweet. So here I am entering one more message. So this is the message which I have entered. Now click on predict. So the result for the tweet is, the sentiment of the tweet is anger. So here for this message the sentiment is anger. Now let us enter one more message. This is the message which I have entered. Now click on predict to predict the sentiment of the tweet. So here we can see results for the tweet is, the sentiment of the tweet is fear. So the message which we have given, for that message the sentiment is fear. Now let us enter one more message. This is the message which I have given. Now click on predict. So the result for the tweet is, the sentiment of the tweet is happy. Now let us enter some more messages. This is the message which I have given. Now click on predict, and the result for the tweet is, sentiment of tweet is love. Now let us enter one more message and find the sentiment for that tweet. So this is the message which I have entered. Now click on predict, and the result for the tweet is, sentiment of tweet is surprise. So in this way, by entering the messages, we can predict the sentiment of the tweet, whether it is anger, fear, happy, love, sadness or surprise. Sign out. And the conclusion of the project is, this project thoroughly investigated many deep learning models for the categorization of short text, including by LSTM, by RNN, by GRU, LSTM, CNN, and an ensemble model integrating LSTM with GRU and CNN. It was determined through thorough evaluation that GRU and LSTM outperformed other models. As a result, the deployment of LSTM was chosen as the final model. In applications like sentiment analysis and news categorization, this model can be used to accurately classify brief text because it was saved to allow user predictions. The project's goal of improving text categorization accuracy for brief textual content was achieved.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.